Hello, everyone. It's so lovely to see guests from India and from across the world. A warm welcome to all of you. Thank you so much for joining in celebrating the life and legacy of Professor Prakash Shetty. I am Manjuli Kawaz from the Division of Health and Humanities, a nascent field in medicine in India, but one recognized and appreciated by Dr. Prakash Shetty. The aim of our division is to connect science with society and vice versa, which is exactly what Dr. Shetty envisaged through his endowment to the Health and Humanities Division and realized through this annual public lecture, addressing the intersection between science and the arts, or an important area of science which affects public life. Our lives have definitely been impacted and overshadowed by the COVID-19 pandemic over the last 2 years, affecting public as well as personal life. Today, we have two eminent speakers who will unpack the science behind the COVID-19 vaccines and its related ethical aspects. A couple of housekeeping instructions. In this online mode of functioning, the audience will only have access to the chat box to speak to each other and the Q&A box to post questions for our speakers. The speakers will address those questions and discuss them only after finishing both lectures. We are also live on YouTube, so there is no restriction on the number who can still join us. I now hand over to our Dean of the Research Institute, Dr. Tony Raj.
Thank you, Dr. Manjulika. Good evening, one and all, and good morning or good afternoon if you're from other continents. A warm welcome on behalf of St. John's Research Institute and St. John's National Academy of Health Sciences to this third Professor Prakash Shetty public lecture. As Dr. Manjulika mentioned, this evening, we have two very distinguished speakers, Dr. V. Ravi and Dr. Anand Ban, who share their thoughts with you through this lecture. I also take this opportunity to welcome all other panelists on this meeting this evening, which includes Professor Anurag Kurpad, Dr. George D'Souza, Reverend Dr. Charles Davis, and all other executives and faculty and other members and guests. Thank you for taking time out this evening and being with us. I also especially like to welcome the family of Professor Prakash Shetty who have logged in, and really thank you for supporting us through these lectures. I now call upon Professor Anurag Kurpad, founding Dean of St. John's Research Institute and former head of Department of Physiology, St. John's Medical College, to introduce the Professor Prakash Shetty public lecture and introduce you to Professor Prakash Shetty as a person. Thank you.
Thank you, Tony. Nandini, I hope you're there. Dushyant, Meghna, Prakash's extended family, Dr. Ravi, Dr. Anand Pan, all the teachers, colleagues, and friends, I welcome you here. And it is my job to describe the man, Prakash Shetty. I have just 5 minutes to describe a many-faceted and multi-talented man who changed my life and changed the lives of many that he met. And so that is not a lot. But to give you just the usual background, Prakash was a graduate and postgraduate from Christian Medical College, Vellore, and then joined St. John's as a faculty member in physiology when neurophysiology was a focus in the department. He went on to become the professor and the head of the department, but also changed the course of that department into a pursuit of nutritional physiology. And he started this as a nutrition research center of the ICMR. There were 5 such set up in the country. So the southern one was located with him. And he built a very strong cohort of young students and fellows who then continued his tradition. He left St. John's to a prestigious appointment at the London School of Hygiene and Tropical Medicine, and then the Food and Agriculture Organization in Rome. But he always stayed in touch with us here, and his students are and will always be loyal to him. He was very well known in his official work role, so I won't go down that path. Rather, let me talk about his other and more interesting facets. As a student, besides physiology, I got to know his love for the history of medicine. Many a free afternoon was spent poring over books to find a forgotten phrase or description. There was no Google in those days. So if you wanted to do a search, it really meant a sneezing search of dusty books over weeks. But that was fun because we would then come together and show each other what we had found. He would also disappear on expeditions with his camera to track down sculptures in temples. And he would go to all the local temples in the area and outside. And he made a very strong case for the appearance of different medical conditions being recognized in the wall sculptures of those temples. He made a record of those. He was just naturally curious, and he turned his questions into a very scholarly way of inquiry. I recall his wandering around the campus here. In those days, it was a pretty wide campus, collecting specimens of the garden lizard or Calotes versicolor. And these aren't easy to collect. These are very sensitive lizards and they run away. But he would catch them with a noose fashioned from a piece of coconut leaf, as he worked with another student called Kariyappa to describe adaptations in the blood of this species, including a more than expectedly rapid clotting time. He never told us why it was more than rapid, but it was a fascinating thing to read. Or the other time when he saw large black ants clustered around a puddle of urine because someone had carelessly let fly on Sajapur Road. That still happens, by the way. If you were to walk down the road, you do get the whiff. But he then took these ants to see what they were after in the urine. And he carefully measured the diameter of their thorax with a vernier caliper as he exposed the ants to solutions of glucose. Yes, of course, glucose, because he too thought that that careless urinator was a diabetic. But then he found they were after the urea in the urine as a source of nitrogen, perhaps. He wrote that paper up and published it in Experientia. And that was a paper that I read as a student. And I was quite fascinated by that. That was the man. And his curiosity made the work in physiology all the more enjoyable. His wife, Dr. Nandini Shetty, is an accomplished and well-known microbiologist from University College London. And she and he would host many evenings for us, his students and his co-faculty, when he had visitors from abroad, or even when he didn't have visitors. They were just very hospitable. But we were a rowdy and boisterous bunch of students, but Nandini was very patient with us. And by dint of never expelling us from the house and entering into the spirit of discussions, she helped along many memorable and lively discussions. So thank you, Nandini. And I think that was an important part of our development. I have very fond memories of this accomplished man, as those of you who knew him will also have. His science and personality were very bright. He inspired us, and he will always have a loyal following. Do enjoy the lectures tonight, and I bet you he would have enjoyed them too, as they are given by people who are every bit as erudite and inspiring as he was. Thank you. Back to you, Tony.
Thank you, Anurag. Manjli.
Thank you, Dr. Anurag, for those personal insights into the lesser known aspects of the life of Professor Shetty. I now request Dr. George D'Souza, Dean of the St. John's Medical College and friend of Dr. Ravi, to introduce him to us. Over to you, Dr. George.
Thank you, Manjulika. Good evening to all of you. It's my pleasure to introduce the first speaker of today, Professor Ravi Vasantapuram. Professor Ravi was a senior professor at NIMANS, where he established the Department of Neurovirology and headed it till he superannuated. I have known Dr. Ravi from the earlier epidemic that we had on H1N1 and more closely in the current pandemic. Dr. Ravi has spent a lifetime in virology. Particularly, his interest has been in public health virology, in the pathogenesis and immune response of viral infections, uh, and in the development of indigenous diagnostic assays. In the current pandemic, he's probably single-handedly helped establish COVID testing across the state, and more recently, he has been made the nodal officer for uh, sequencing the COVID virus in the state of Karnataka. So, with these few words, I think he's the right person to tell us about the relationship, the COVID vaccination, and I hand it over to Dr. Ravi.
Good evening. It's a great honor to be asked to deliver the third Dr. Prakash Shetty Memorial Lecture. I had the privilege of meeting Professor Prakash Shetty almost 3 decades ago, and Professor Prema Bhatt introduced me to him in the corridors of St. John's Medical College. I, of course, know Professor Nandini Shetty because she's from the same fraternity, and I do have fond memories of interacting with her as a professional colleague. Professor Anura, Professor George D'Souza, Dr. Tony, Dr. Anant Bhan, Dr. Manjulika Vaz, Dr. Charles Davis, ladies and gentlemen. It's what I have been asked to talk is about something related to COVID, and so what I have done is to put a talk together entitled "The Science Behind COVID Vaccines." So let me share my screen with you. Just give me a second. I hope the screen is visible to all of you.
Yes, Dr. Ravi.
Yeah. Dr. Prakash Shetty was a very inspiring person. I have known about the large body of his work in nutrition, and later on his work on food security. So it's a great pleasure to give this oration and a great honor. What I will do the next 15 or 20, 25 minutes is to talk to you on introduction to SARS-CoV-2 infection and its immune response. And under the science behind COVID vaccines, I will walk you through on the way vaccines are developed in general, the technologies and the platforms used for COVID vaccine development, and to answer some important questions. Do vaccines work? What is their efficacy, their variants and vaccines, the side effects, and the COVID vaccine scenario in India and challenges in COVID vaccinology, and end with a summary. We all know so much about this virus in the last 1.5 years that it is a respiratory virus transmitted by droplet infection and aerosols in closed spaces. It is a spherical virus. It has an envelope outside made of lipid or fat derived from the host membrane, and embedded in this envelope is a most important protein of the virus, which in this cartoon of the virus in the center you see as a hammer-shaped red colored protein. This is called the spike protein. Of course, the virus has many other proteins as well. This envelope encases a shell of the virus, the nucleic acid, and then the shell contains a single strand of ribonucleic acid as the genetic material of the virus. The spike protein is the most important because it helps the virus to attach to human cells and animal cells and facilitates the entry of the virus shell into the cell so that it can uncoat and start multiplying. So attachment is endowed on this protein. So also the properties of immunogenicity, meaning this is the most important protein that affords protection. The responses, the defense system's response to this protein affords protection against the infection or the disease mainly. The virus enters through the nose, the mouth, and mucosal surfaces, sometimes through the eye, and it multiplies in the upper throat and in the behind the nose, and then goes down, and in some individuals it goes down to the lungs and induces a very aggressive defense response. Now we all know that the defense system or immune system as it is called is a system that has several components in it. The first set of cells are the ones that pick up a foreigner that invades, processes, and presents it to the cells that mount a defense response. They are traditionally a type of white blood cell known as lymphocytes, and in lymphocytes we have two categories: helper lymphocytes and cytotoxic lymphocytes. As the name indicates, the helper lymphocytes facilitates a very positive response in neutralizing the virus. The cytotoxic cells are the ones that actually grapple with virus infected cells. They're akin to soldiers and they kill infected cells. So this is what happens. Majority of the people in SARS-CoV-2 infection, fortunately, are mildly symptomatic or asymptomatic. That's about 80 to 85%. And the remaining 15-20% are the ones who manifest some form of the disease, either mild, moderate, or severe, and mortality is usually anywhere between 1 to 4%. How do vaccines work? Vaccines are a shortcut to availing protection without getting infected. If you get infected, you may develop disease, but we want to protect people without them getting infected. And it's more than a century-old science where we inject the human body or we deliver parts of the virus or the whole virus, either inactivated or attenuated. We give it to the body so that the defense cells recognize this virus, viral proteins, and then program the defense system for appropriate responses in terms of T helper cells or CD4 cells as they're called, and the T cytotoxic T cells. And this response usually lasts a couple of months. And while the body is mounting the response, it also has a strategy that it will keep the memory of this virus in its bank. And there are a set of cells which are called memory T cells and memory B cells, and they will reside in the bone marrow. And should a person get infection after the vaccine, the response time is shortened tremendously in a log scale, and the army goes into multiplication and action and neutralizes the enemy. Vaccines have the following advantages over natural infection, because the amount of the dose of the immunogen or the protein, the important viral proteins given is much, much more than what you experience in natural infections. And generally vaccines speaking, are given in multiple doses. There are vaccines that can induce a very potent response in a single dose, but the COVID vaccines are, at this point of time, almost all of them excepting one, that is the Johnson & Johnson vaccine, are two-dose vaccines. The logic behind two doses is the first dose, the immune system gets primed, knows a lot about its enemy, and you give a gap and then you boost. At that time, the reaction time is much less. And not only that, the quantum of response you build is much, much higher. So that's the logic of vaccination. Do we need COVID vaccines? I will just spend a few seconds on this slide. History has shown us in it that any viral infection, most of the viral infections, some of the bacterial infections, also like diphtheria, polio, measles, whooping cough, all of them, the globe has been able to conquer it or minimize it because of vaccination. And these curves here tell you after introduction of vaccination, it will come down. It's the most practical, attractive possibility available to mankind, because the much easier one though is changing our behaviors, and that's the most difficult to implement. And the waves of COVID infection have told us that it will occur in waves, because this is a brand new virus and it will catch every person who's susceptible. And the person gets protection either only through infection or through vaccination. Okay, how are vaccines in general developed? When a vaccine is developed prior to the COVID era, or even during the COVID era, or even now, there are two broad phases it goes through. The first is preclinical testing, and the second is clinical testing. Preclinical testing means initially developing a vaccine, designing a vaccine, and evaluating it in animals. Only if it is safe in animals and only if it's producing the desired response, the regulators will look at the data, the experts will look at the data and allow it to become to clinical stage. Traditionally, for COVID vaccine, there are two types of animals used, small animals and large animals. Small animals are the mice and the ferrets, and the large animals are the monkeys, the rhesus macaque monkeys. What they do here is this animal testing phase is used to standardize how much of dose to give, what should be the interval, what should be the formulation, and does it produce a response. Traditional vaccinology prior to COVID, this used to take up to 5 to 10 years for this phase. But with COVID, because of the pandemic situation, unprecedented collaboration and emergency authorizations, this got compressed to a much, much less time. In fact, both the clinical and preclinical phases and the clinical phase was completed in a matter of 9 months. Traditionally, it will take several years, 5 to 10 years for the whole thing to happen. In the clinical phase, there are three important subsets or classifications. The first phase is on usually up to 50 to 100 volunteers to see if the vaccine is safe. So the vaccine is given and the person is monitored for any adverse events. A whole lot of screening of their metabolic and other profiles is done. Genetic damage, whether it's happening, all that is done. If that they pass through that, they goes to the second phase, and that's to evaluate whether the vaccine is doing its job or not, called immunogenicity. And the third phase is the acid test in the community, give typically in thousands, in case of COVID, 25 to 50,000 volunteers. 1/3 of them or 1/4 of them do not receive the vaccine, but receive a solution which is innocuous, resembling the vaccine, which we call placebo. And then we compare the rate of infections in the vaccinated group as well as the placebo group to calculate efficacy. The last phase is still going on, and that's phase 4, and that is post-marketing surveillance. And that usually for vaccines, it goes on for several years to see long-term side effects. The platform technologies used in COVID are very interesting, because prior to COVID, we had only 3 or 4 technologies. One was to use the whole virus, either in a killed form or in a form where the virus disease potential has been removed, which we call attenuated viral vaccines. We do not have any attenuated viral vaccines released for COVID yet. Killed vaccines, yes. Covaxin from India is an example. COVID brought on a lot of new technologies, and not only brought on technologies, it's also being used in human beings. For the first time, we are using vaccines where the COVID protein, the spike protein, is piggybacked, or that gene is inserted to another unrelated virus, like adenovirus, to give an example. And that adenovirus carries the spike protein of SARS-CoV-2. It is able to infect human beings, deliver the spike protein, and then it ceases to multiply. This is called viral vectored vaccines. Another virus is being used as a vector to carry SARS-CoV-2 protein. And subunit vaccines have been used in human beings earlier, meaning only the purified protein of the virus is used. A classical example is hepatitis B vaccine. But for the first time in the history of medicine, genetic vaccines have been used. There are two types. One is using genetic material of SARS-CoV-2, not the entire genetic material, the gene for the spike protein. And this is an RNA, as we know. So the RNA is encapsulated, protected, and delivered inside a cell. That's fantastic technology. It's been masterminded. It's working very well. And this is going to have tremendous implications for the future. The other is to use the DNA form. You convert the RNA into DNA, especially for the spike protein gene, and then deliver the gene into cells so that gets translated into protein. Both these vaccines, genetic vaccines, go inside a cell and get translated into protein, and that protein immunizes the virus-like particles are empty shells where genetic material is removed. This is still not licensed for COVID use, emergency authorization use. So these are the technologies. Do COVID vaccines work? You should understand the term efficacy. Efficacy means, what do you make sense of efficacy? And I've given a cartoon on the right. Vaccine efficacy is the comparative measurement of infection in the vaccinated group versus the placebo group. So it is calculated in clinical trials by comparing the infection rates in COVID vaccine. It's the infection rates between the vaccinated group and the placebo group. It does not mean that if the efficacy is 80%, that 20% will develop disease. No, that is not the way to interpret vaccines. Okay, and efficacy is a magical number. Efficacy also, one has to be very clear. What we are measuring in COVID vaccines after vaccination is whether a person becomes SARS-CoV-2 positive or not. To me, this is misunderstood by many people, including many of the medical professionals. If you look at the efficacy, reported efficacy in phase 3 trials for vaccines that have been licensed across the globe, close to a dozen of them, the reported efficacy varies anywhere between 57% to 95%. That means what? That means a proportion of people who are vaccinated did get SARS-CoV-2 infection. But what we should be looking for is the ability of a vaccine to protect against disease. For some reason, the human race is very greedy, and everybody wants protection against infection. There are hardly any vaccines that protect against infection. What do we want from a vaccine? We want a vaccine to protect against disease and certainly against death. Now, all COVID vaccines are delivering it. Why are we belaboring ourselves and arguing and saying, should I take this vaccine? Should I take that vaccine? Irrespective of which vaccine you take, be sure the level of protection, and my definition of protection is there is no disease, or the chance of getting disease is very, very less, and there is guarantee for majority, over 95% of people, against death. So that is protection in my interpretation, and I want all of you to look at it from that. After taking vaccine, you will get infected. And what does data show? Data shows very clearly that this is the curve, the epidemic curve in England. England has had 3 waves. The first and the second, during the first wave, the number of hospitalizations almost paralleled the number of positive people that were detected. In the second wave, it was less. And by the third time they had the third wave, 70% of the population had already been immunized with 1 dose and nearly 50% immunized with 2 doses. The hospitalizations were negligible, and so also deaths. And deaths and hospitalizations were also very common in people who had not received the vaccine. So to cut a long story short, do vaccines work on the ground, not only in trials? Trials is a very controlled environment. This is actually field efficacy, effectiveness. 2 large cohorts in India have been followed. Both are police personnel, one in Tamil Nadu and one in Punjab. And these results, I think the Chennai one is almost in print now, or it's in the proof stage. Both show one thing, that after 1 dose of COVID vaccine, 82% of people were protected against serious disease and death, whereas the Punjab one was higher. Both have, after receiving both doses, 95% of the people are protected. There's a big debate in social media on whether vaccines will protect against all these new emerging variants. Or the virus will continue to mutate. It's his business. And it is endowed with a lousy enzyme that cannot copy properly. It makes mistakes. So every time the virus multiplies, there are mistakes in the virus, and that impacts the structure of the virus and the behavior of the virus in terms of infections. So we have at least 4 major mutants that have emerged, which are of concern, meaning they spread to large populations very quickly. Alpha, beta, gamma, and delta. I won't go into the details. Alpha was detected in UK, beta was in South Africa, gamma was in Brazil, and delta was first detected in India. Now, there's a lot of hue and cry on whether the vaccines made against the parent Wuhan virus protects against these variants. The short answer, and publications in NEJM have shown that yes, it does protect against serious disease and death, but in preventing infections, they vary. And among these 4 variants, the resistant guys are the beta and the gamma. The Brazilian and the South African ones can escape immune response, but that does not mean that they will not protect against disease or death. Irrespective of which vaccine, whether it's RNA vaccine, whether it's whole vaccine, whether it is a killed vaccine, all of them, there is protection to varying degrees against infection, but definitely against death and serious disease. India has so far given emergency use authorization for 7 vaccines. And one of them is the first time in human history is a DNA vaccine made by Zydus Cadila. We have 1 RNA vaccine licensed, the Moderna in India. We have viral vectored vaccines, at least 3, the Johnson Johnson, AstraZeneca, the Serum Institute vaccine, and the Sputnik vaccine, which is also a Russian viral vectored vaccine, and our own Indian indigenous killed vaccine from Bharat Biotech Covaxin. There are various other vaccines in the clinical trials in India, and these are our own subunit protein vaccine from Biological Evans. And then we also have the Bharat Biotech nasal vaccine, a very interesting vaccine. Being a co-chair of the committee that's reviewing this data in DBT, I've been impressed with the preliminary phase 1 and preclinical and phase 2 data that will be that's being generated. Novavax is a protein vaccine, and Serum Institute is also looking at another recombinant protein vaccine, Covovax. India has started immunization January 16th. After a lot of stumbling and change, continuous evolution in vaccination policies, now it has been opened up for all adults above the age of 18. In the last month, we are doing exceedingly well. We have administered 84 crore COVID vaccine doses. That is 3/4 of the adult population where the vaccine has been licensed have received at least one dose. No, actually, of 60%, 40 to 60% have received one dose. It depends on the city and the area we are talking about. Totally 84 crore dose, and about 15 to 20% of people have received both the doses. We have a long way to go, but if we continue this kind of aggressive immunization, I'm sure we will be able to cover the population at least with one dose by another 4 to 5 months. And that itself is great news because it brings down the policy, as I said, has been dynamic. I won't go into it. Over time, it went on changing. Right now, anything that is injected to human being is going to produce side effects. Even if it is saline or it is water, there will be pain, there will be irritation, and some of them may show some local reaction. So these kind of things happen even with COVID vaccines. But the large debate out there is, what are the benefits versus the risks? And the benefits far outweigh the risks. The chances of getting adverse events, serious ones, after COVID vaccination is very, very less. I won't dwell much into it because I suspect Dr. Anant Maan will probably address some of these questions in his talk. There are questions people keep asking me, so I put it up. Can we interchange vaccines as a policy in India? No, but several countries have permitted. France and Germany permit intermixing of vaccines. They have done trials giving one dose of vaccine A followed by vaccine B. What combination B should come first, A should come first, I think they have to be worked out. Most of the studies have shown if you give viral vectored vaccines followed by boosting with an mRNA vaccine, the response is very good. Why should we mix vaccines? For two reasons. A, if there is non-availability, there is shortage, then one may have to use two vaccines, or to boost the immune response, to get a better immune response. How long does immunity last? Whatever available evidence indicates that 6 to 9 months it lasts. Remember, for any vaccine, after you give a vaccine, the immunological reaction will last. Antibodies and cells will be there for 3 to 5 months. This is for every vaccine. There are some vaccines, of course, where it remains for a very long time. Most viral vaccines, in 3 to 6 months, antibodies, which is the only easy way of measuring protection that is available to us today, wanes. That does not mean protection does not last. There are elegant papers which show that in the bone marrow, the cells remain for a very long time. So that leads us to the next question, the debate that is raging now, whether there is a need for a third dose of COVID vaccine. My personal opinion, based on science, is there is no clear-cut evidence that we should give a third dose. Remember, waning of antibodies does not mean there is no protection. The fundamental attribute of the immune system is memory. If you give 2 doses, and all vaccines have shown they induce memory cells, so memory will be there. So should you get an infection 3 to 6 months after COVID vaccination, your memory response will kick in and it should protect you. Unless there is compelling evidence generated saying that no, there is no memory and memory does not last, then and then only I think a third dose is warranted. This is based on evidence I'm talking. Of course, this is an emotional decision. Many countries are recommending. USA, for example, has recommended for the elderly, especially the vulnerable and the immunocompromised. But in my opinion, these are not decisions based on science, but more on sense and emotions. There's several challenges in COVID vaccines: availability, equity of distribution, reaching the unreached. The first 60-70%, it's very easy to give vaccines to people. The last mile is difficult because not everybody comes to a healthcare system to take vaccine. So we have to reach vaccines to them. Breakthrough infections, people are worried. Breakthrough meaning after taking 2 doses of vaccine and 2 weeks later you get an infection. Thank God, all the evidence says it is very mild now. Whether a new variant will come, I'm not an astrologer to predict that. So far, it looks unlikely. If you want me to take an educated guess and viral astrologer, I will wear that hat and tell you any better variant other than Delta, which is the most infections, is not there on the horizon. Delta is the best variant that has come in terms of its ability to infect large number of people. So these are some of the challenges in COVID vaccination. But what is really defeating is the myths. There are a number of myths, and myths are contributed by loose discussions on social media, and everybody becomes an expert. They say it changes your genetic makeup. It's absolute nonsense. It does not produce infertility. It is effective even during monthly cycles of women. There is no reason to believe that vaccine should be taken at a particular time. There is no egg in any of the vaccines. Definitely, it was not rushed. Safety has been the topmost priority for COVID vaccines. India is a country where these kind of myths do exist. I wish this guy would attract gold coins. Then at least it would have made a little more sense. Unfortunately, he's attracting steel items on his body. And this is media propagated myths that you become magnetic after vaccination. Okay, breakthrough infections, as I said, will occur. The frequency is very less. At this point of time, it's 0.4%. To summarize then, SARS-CoV-2 is a new pathogen. It is contagious. It spreads quickly. You can get immunity either through infection or vaccination. If you get through infection, it's a lottery. Whether you will get serious disease or not will depend on a variety of factors. If not infected or vaccinated, the virus will catch you. It will catch every susceptible human being on the planet. That's survival for the virus. There are several challenges in vaccinating large amounts, right from production to socio-political barriers to accessibility, equity, distribution, whole lot of things. Enhancing community engagement should be our way forward. As I said, first 60-70% you can cover very fast. The remaining 30% are the doubting Thomases. So we have to really burst these myths and make things very clear to people that vaccines are safe, and also the benefit you get out of vaccination is far more. The road ahead is going to be bumpy. I'm very fond of saying it's a road with many speed breakers or speed humps. Every time we reach a hump, we should slow down. But remember, irrespective of whether you get vaccinated or not, you should continue to wear masks, because that is the best method of protection that you can afford to yourself. So thank you very much. Please protect yourself. Vaccination is available. Wear masks when you go outside.
Thank you so much, Dr. Ravi, for that fascinating journey through the spectrum of COVID-19 vaccines. And I love those metaphors that you used of the army and the memory of the immune system. We'll get back to questions later. I now have the honor of introducing Dr. Anant Ban to all of you. I must tell you that while he is located in Bhopal, Madhya Pradesh, he is Namavaru. He is one of us, a graduate of Bangalore Medical College, who went on to do law, ethics, and public health from the University of Toronto. He got his grassroots experience in community health as a fellow in Sochara here in Bangalore. and in the Center for Studies in Ethics and Rights in Mumbai. Anant has been an outstanding researcher, faculty member, and policy advocate in the fields of ethics and public health at various institutions across India and the world. He has extensive publications in these areas. I have been fortunate to have worked closely with him and to appreciate his depth of understanding of complex bioethical issues. And this was as part of the Global Forum on Bioethics in Research, while he was president of the International Association of Bioethics, and as an advisory member with IRV. We also looked into the ethics of controlled human infection model studies and the need for public engagement. In recent times, he has been active on various television channels in print and social media, discussing the ethics and public health concerns around COVID-19 and COVID-19 vaccines. Thank you, Dr. Anant Ban, for being here, and I hand over to you.
Thank you so much, Manjulika. It's an absolute honor to be delivering the Professor Prakash Shetty Memorial Lecture, especially along with Dr. Ravi. And it's also a privilege to be doing this for the SJRI community. Many friends at SJRI, and I've always enjoyed my visits and my interactions with the many friends I have there. So the task which I was assigned was to maybe follow up by that illustrious talk, which is always difficult to do, by Dr. Ravi, and maybe take you from the science to focus more on the ethics of issues around COVID-19 vaccination. And of course, this is a very complex area, as you have already seen, but also very relevant now as we've been grappling with this pandemic for the past many months. So I would start by first acknowledging the many lives that we have lost. And these, of course, include doctors, nurses, paramedical staff, many other frontline workers who have sacrificed their lives trying to protect the larger community. And this, of course, we owe a lot of gratitude to them because without their contributions, obviously, we would not have been able to handle the various waves that we've talked about. So many of you would know ethics because, of course, those of you who are from the St. John's community are also exposed to ethics. So it's one medical school and research institute probably which focuses on ethics quite early in its training. Unlike many other places, even with ATCOM coming through now in other medical schools with NMC, I think there is a lot to do for it to be sort of become centerpiece in medical education. So of course, ethics is derived from the Greek word ethos, or behavior. It helps us grapple with right versus wrong, moral dilemmas, and especially when there are values conflicting, when there are ethical dilemmas, when it's not easy to make a decision, when you might have a lot of conflicting scenarios which are playing out and you don't really know what decision to take, say as a clinician or as a public health researcher or as a policymaker or as someone who's an administrator. That's where frameworks of ethics would be really useful, and because this helps you go through these scenarios systematically and come out with potential solutions which would be useful. Now we're talking obviously ethics, and we are also talking vaccines, and Dr. Ravi has given you a whirlwind introduction to COVID-19 vaccines. I don't need to go into details, but it's just astounding that, in a very limited amount of time, we now actually have almost 105 vaccines in clinical trials right now, out of which 35 have already reached the final stages of testing. And there are actually a few already also additionally in preclinical testing. So it just shows us that, when science is leveraged, it is actually possible to do it. Should also make us question why something like this not possible, say for TB, and a whole lot of other diseases which have been around for many years. Why is this kind of investment of science not being leveraged in those conditions? Perhaps that's something to reflect on once the pandemic has relatively eased off. Now, of course, that means that we've had really some great science wins. We've done some really high quality randomized control trials, including in India, in relatively short periods of time. We've done studies also which have helped very clarify that certain interventions don't work. For example, convalescent plasma therapy, that was a large study done by ICMR, the PLACID trial, but also on vaccines. And, this has given us a good idea around safety, efficacy of drugs, vaccines and therapeutics. tells us clearly what works, what doesn't work. The large trials, such as the Solidarity trial, have given also, literally with thousands of patients data, which is very convincing in nature, so that, there are no doubts around these. And to be able to conduct these studies at the time of a pandemic, research is always complex and difficult to do, but to run such large studies is something which is really, really commendable. Yet at the same time, we have also seen issues with some mediocre science, and we've seen a lot of poor quality studies. If you go to CTRI, the Clinical Trials Registry of India, you will see a whole bunch of studies which have been registered for COVID-related topics. But the quality of evidence which is being generated often is, fairly low quality. You might have choices being made around going with observational study designs, not choosing, for example, to go with gold standard designs, sometimes decisions around open label or blinded studies. You've all, I'm sure, received links in your WhatsApp or your Google groups to surveys of various kinds. Many of these surveys don't really have ethics review, often are done without consent, etc., not really talking about privacy confidentiality. And similarly, there are some concerns around vaccine science as well. And if the one thing which the pandemic has reinforced, and this is not rocket science, I think all of us were aware of this, that there are issues with our health system, that it is deficient, there is leaky infrastructure, there are human resource shortages, there's been a long systemic neglect, not just funding related, but in many, many other ways. But it also tells us that there have been major gaps in our regulatory and ethics oversight systems, and some of those have been reinforced during this pandemic. So what were those kind of ethical concerns which we might want to talk about? So Dr. Ravi already spoke about the fact that traditional vaccine development took many, many years. The minimum probably we've seen for any other set of vaccines pre-COVID is at least a few years. But in COVID, everything has been collapsed into literally under a year or slightly over a year in some cases. And we have vaccines which are then being largely used. What should then be the overarching regulatory and ethics paradigm for that? And I think there are many people who have argued that just because you're going through a pandemic doesn't mean that we can excuse the requirements to have high quality ethical and regulatory oversight. In fact, it should be reinforced at times like this. So the importance of the kind of work that you're doing from a scientific and social value perspective, ensuring that rigorous design is built into the studies that we do, that there is analytical integrity and that this is communicated. It's not just a matter of saying that the science is all great, but no one really knows how to judge it because it's not been published or it's not been put in the public domain. Trials need to be reported completely, promptly, and consistently with pre-specified analysis. And again, we have seen many situations where protocols are not put out, they're not made, they're not shared, or you don't have publications, you have regulatory approvals happening, but months later, you're still waiting for data on efficacy and safety to be published. Now, that is not to say that these vaccines or any other intervention might not be safe or efficacious, but you also have to follow the requirements of good quality science, which includes that requirement to share. And of course, this should be something which we should be encouraging and insisting. The concern also, perhaps in a lot of discussion is, are we taking shortcuts? And in some cases, perhaps this is much more of a concern because there doesn't seem to be a clarity around how decisions were taken, on what basis were they made, was adequate data available, say, on safety and efficacy before a decision was made to allow for a drug to be used. There have been drugs which have been approved, whether those be non-allopathic drugs, some allopathic drugs, some combinations, where that seems to be in doubt. Around vaccines also, sometimes there's been a lack of transparency and data being made publicly available, which has led to questions. Again, not to say that that means that those vaccines might not be working or might not be safe, but it's not enough for that information to be situated within a small group of people like a committee in Delhi. It should be something which is more explicitly publicly communicated. And that's where I think the requirement for transparency becomes important. So being transparent about what kind of designs are being used, what are the kind of protocols, what is the statistical analysis plan that you have, what are the efficacy goals that you have built in, how are you going to evaluate a vaccine in a clinical trial, which is a more controlled environment, as all of you know, but also when these vaccines are actually being rolled out. So the real world effectiveness, which Dr. Ravi was talking about, When will these results be available? How will they be communicated? Who has access to them? If you're going to use interim analysis, then what kind of interim analysis are you using? What criteria are you using? How are you conducting these studies? You will remember that there has been some controversy around at least some trial sites in clinical trials for vaccines done in India. And those concerns have not been responded to. Issues around consent, issues around probable incentives, issues around adverse events perhaps not being responded to. And I live in a city where there was one site as well where those concerns were very much a major issue. And I really haven't seen a resolution from the regulator or some of the co-sponsors. And that's unfortunate because I think one of the most important parts of doing a good quality clinical trial is ensuring that our research participants, if there has been some cases where there are concerns, those concerns should be addressed and responded to. Of course, what's also sometimes been unclear is what are the kind of regulatory boards which have been set up? Who are the members of these regulatory boards? Why is that information not publicly available? Why do we not know if there are conflicts of interest declarations or not? And what are their relevant qualifications to be sitting on these committees? This should be all in the public domain. There's no reason to hide it. It actually might reinforce and make people trust the structures more. If you don't do that, if there is opacity, that perhaps will raise more questions. And also the criteria for decisions around emergency use authorization, on what basis in Indian law are these decisions made, should be publicly communicated. The other issue which we saw was more political in nature, where vaccines started to become election plank, right? So people were talking about how vaccines will be available for everyone in a particular state. They were not talking about how health systems would be strengthened so that any future waves or pandemics would be better addressed. But they started talking about vaccines once we started to get information that vaccines are on the horizon. So there was a lot of vaccine populism, there was vaccine nationalism, but there was also sub-nationalism. So some states saying that, we will immunize everyone in our state. Someone else says, yeah, we will also immunize everyone in our state, but no one really talking about how are you going to equitably distribute the vaccine across the country. And of course, this is not unique to India. This is also something which the WHO identified as a major issue, that by actually being too much inward looking and not having the concept of solidarity at heart, which is an important public health ethics value, we might actually be extending the pandemic, not shortening it. And this will, of course, have economic implications. It has social implications. It has implications on all our kids who have been away for school, as you know, for many months now. So many people have been exploring these issues. I was part of an author group which wrote up this white paper, which might be interest to some of you if you're interested in looking at also more of the science and also the ethics, etc. involved. And there is a whole chapter where we've discussed some of the ethical issues with decisions around emergency use authorization, but also serious adverse events and how they should be handled. And one of the important issues here is what happens if you have an adverse event, especially a serious adverse event. And why is it that we've not really been able to figure out this whole issue of compensation? Why are we so hesitant in acknowledging that there is a very, very minute risk, if often, of some kind of serious adverse event happening? And if that happens, it's much better to, of course, do a good quality, quick causality analysis, not literally take months, but at least, as happens in good regulatory oversight systems, do it, say, within 4 weeks. And then if relevant, then of course offer compensation to the person who might have had that SAE and or his or her family, if that person unfortunately has lost their life. It is rooted in, of course, the requirements of justice, the fact that many of these individuals are participating in a large public health effort. And it, of course, satisfies the requirement for equity and a holistic response to the pandemic. Now, issues are also raised around the fact that hesitancy was a concern, and this became, of course, a major public discussion early in the stage of vaccine rollout. If you remember, around January, you had these kinds of letters being written, sometimes by residents talking about the fact that they were not comfortable with one vaccine or the other vaccine. They wanted more data before they would agree to take it. But sometimes we don't really understand the underlying complexity of issues, why people are reluctant to take an intervention. And especially in parts of rural India where the health system has hardly even touched them. Even now, if you go in with a vaccination program which is focused on adult vaccination, which has never been tried out, where people feel that many of their health concerns have never been addressed, and you suddenly have this very active outreach happening for one single disease vaccination, then they will have concerns, because the structural issues around equitable access to health services are not really being talked about. You're only talking about one single program. Not to say that that doesn't mean that we should be encouraging more and more people to get the vaccine, because it's important, especially at the pandemic time. But we have to also look at the larger picture of what are some of these underlying issues, why sometimes there is a reluctance to take vaccines. Now, another issue, which of course is important, is the issue of corruption. And this, of course, is not, again, very unique to India. The fact that certain people could get access to vaccines even before they were eligible as per the prioritization groups which had been established. And this happened in the US with officials who had invested or donated money to nursing homes where there were a lot of vulnerable individuals who were getting vaccines and somehow managing to leverage that to get vaccines of their own. But we also started seeing that in India, quite early when vaccines started to become available. There was, of course, a shortage. These were only available to, say, priority groups like frontline health workers. So these kinds of ads that you could go to for a vacation to Russia, get your shot of vaccine, go around the city and come back. And even if you did not have access in India, you could hence access vaccination abroad. And this, of course, you saw perhaps in Bangalore as well, which is, given the IT sort of network there, the fact that people were already offering to give access to vaccines for bitcoins, etc. So again, tells us something that, within the larger moral issues that we talk about, it's also important to talk about corruption. Because if you're talking about good quality systems for priority setting, say for a scarce resource such as vaccines early in the distribution stage, then we really need to have standard criteria. And that is also extremely important to build trust in the health system and its efforts to vaccinate. And this should be done in a way that it is transparent, so that people understand how decisions are made around who's within the priority group and why are they in the priority group, and this justification being made public. Doing it in an inclusive way, so that you announce that this is the criteria that we have used, this is the final priority groups that we have identified, but allow people to appeal. Because if they feel that a community that they belong to, or a group to, or a subgroup that they belong to should also be part of those priority groups, have some mechanism for them to be able to appeal and be heard. You might finally not agree with their appeal, but at least they should feel that they had a chance to engage with the decision makers. Decisions should be applied consistently so that this is objective in nature and not subjective in nature. And folks who are taking these decisions should be accountable. But to hold them accountable, you also need to know who they are and how are they taking those decisions. And sometimes that information might not be as easily available. Now, we also have to acknowledge on the ethics and equity side that there are various barriers for people to get vaccination. And one of them can be a barrier around gender. Access to healthcare, even pre-COVID, was gendered. The fact that women in the family are sometimes the last to access healthcare, because the healthcare of men in the family, children in the family, is prioritized over their health needs, which often means that women only report to facilities when they really have serious disease, or they are in a lot of pain, or they are at a disease stage where it's not at all possible for them to be able to handle their responsibilities, their domestic work, etc. And that's when families might allow them. So understanding that the gender roles, norms, culture is also sometimes the reason why vaccines are not accessed by, say, women or gender non-binary individuals in the same way that men might be able to access vaccines, and that those differential in terms of equity was also available when we started analyzing the data. Then there was a few publications looking at it both globally as well as in India. So something for policymakers to think about, that how is it that we can address these kinds of barriers, because that will mean that our population coverage goes up, but we are also enhancing our population coverage of vaccines in a more equitable manner. And that also applies to other individuals or communities which are vulnerable. There was an adequate data over the past many months, including publications in peer-reviewed journals, which showed that individuals such as those with severe mental illnesses, especially in institutions, were at high risk of COVID and hence should have been a priority group for vaccination. But those were not considered often in many contexts, including in India. And actually, it was only through court intervention that now states have been asked to go in and find these individuals and make vaccination available to them at the doorstep. Also true of disabled individuals, because individuals with disability often find it difficult to go to facilities. Facilities might not be accessible. They might be too far from their house. So taking vaccines to the doorstep, which to the credit of the government has started to happen over the last few weeks, is something that we should be also more proactively following up. The one issue which is also relevant here is issue around access, and this is a global issue. The fact that there are countries where the doses administered per 100 people is much over 100 doses. So this means that there are countries where sometimes for every citizen they might have multiple doses available, whereas there are many other parts of the world where vaccine access is still much lesser, where there is a large segment of the population which has not accessed the vaccine. In fact, there are segments of the world where even priority populations like doctors, nurses, paramedical staff, those who you would consider critical during a pandemic, have not been able to access the vaccine. And yet we are having richer contexts where vaccines are available. Now they're talking about potentially doing multiple doses, etc. This is partly also because there is a global inequity, and also because richer countries have not really honored their own commitments around making vaccines available globally. They have a large outstanding commitment. They have delivered a very small part of the commitment to make more vaccines available globally. And this is where this whole issue of we have had a very fancy global COVID-19 summit, which was just hosted a few days ago by President Joe Biden. And they made a pronouncement that one aim is by September of next year, 22, to vaccinate at least 70% of the world's population. Now, that's a very fancy ideal. I mean, it's a good goal to have, but do we really have the pathway to get there? Because almost as Madhu points out, while 6 billion vaccine doses have been administered globally, only 2% of people in low-income countries have received at least one dose. And this is something which should worry us, because already richer countries, as Dr. Ravi was indicating, are talking about booster doses for their citizens, a third dose, while many other countries are still struggling with getting even the first dose out. And this is a discussion which is already starting to happen in India as well. So this is news from the Economic Times as of today morning, which talks about already this discussion among some medical professionals, public health experts, talking about booster shots needed in India, especially for populations where there might be waning protection post-vaccination. So we are already talking in India as well on this, recognizing that there is a significant segment of our population still without access to even the first dose. So that is something for us to grapple with as a moral dilemma, both at the global stage, but also in country, how we should be responding. Because quite honestly, this is where perhaps the envelope becomes a larger envelope. It is not just about equity, it's also about justice, because why is it that many of the poorer parts of the world do not have access to vaccines? What are the barriers? Are the barriers intellectual property related, because many of these vaccines are being produced by global multinationals, which are reluctant to do technology transfer, where there are barriers because these MNCs sit in rich countries, which are also not very willing to facilitate transfer of technology, facilitate transfer of know-how. And this, of course, requires a larger moral discussion around what kind of a world do we visualize we should have in the future. Now, in one of the issues which has also been discussed from an ethics perspective is, should we make vaccination mandatory? Should we make it mandatory for doctors, nurses, medical students, school teachers, as we start talking about opening up schools? And in some states, obviously, that's the schools are beginning to open, restaurants, delivery executives. And one needs to really grapple, should you be forcing someone who might not be willing to get a vaccine? What is the plus and minus there? Can you violate someone's individual liberty and autonomy to make a decision in the interest of public health? And what do you need in terms of an ethics framework to do it? So, some of the issues we've talked about in this policy brief, which was written up by a working group I am part of at the WHO talks about making sure that we have principles such as the necessity of that kind of a step being satisfied. Is this a proportional response, making vaccination mandatory? Is there sufficient evidence of vaccine safety? Is there sufficient evidence of vaccine efficacy and effectiveness? Is there sufficient supply before you make it mandatory? So that if you are expecting people to take the vaccine, but there is no vaccine available at the local health facility, then how will they actually be able to do it? Is there trust in that decision? How have you built a larger engagement so that people are satisfied that this is indeed needed and it is based on sound science and sound ethics? And what is the process involved in that decision making, which also is an important component of that. So sort of trying to summarize many of these issues. Of course, it's always difficult to do it in a 20-25 minute talk, but there have been issues which are ethics and regulatory related with vaccine R&D. We've had really science help rescue literally millions of lives during the pandemic. Yet at the same time, there have been also gaps which I think we need to talk about and think and reflect on. More need for community and public engagement, the need for vaccine allocation frameworks, which help enhance the trust in rollout of vaccines, ensuring that advocacy and communication is at the heart of the way we respond to the pandemic, making sure that we figure out when targeted vaccination for priority groups happens versus when general vaccination rollout happens. What are the kind of challenges when you are talking about vaccinating the entire population the first time it's being done in India? What are the kind of cost implications? What are the implications of this on other disease conditions? What are the implications of this on other vaccine preventable diseases? Is our focus on COVID vaccination going to also mean that routine vaccination perhaps might be taking a backseat, because it's the same vaccinators in most cases. It's the same antenatal midwives who are going out and doing vaccination. It's the same nurses. So without actually enhancing our human resources, are we actually going to be able to manage both large-scale vaccination across the population and keep our vaccine program, the universal immunization program, running in the same way as pre-pandemic? And how are we going to talk about building health systems enablers such as supply chains, hiring more vaccinators, etc.? So in summary, I think as this Lancet cover, and I use this now a lot in my talks, because I think it makes a very important, though simple point, that this pandemic has reminded us that this is an opportunity for us, for all of us to think about what kind of a society would we want after the pandemic has receded, and what are the kind of structural changes, what are the kind of ethics reflections that we need to be able to enable that. Thank you so much for your attention.
Thank you, Dr. Anand.
Thanks very much, Dr. Ban. That took us not just through ethical issues, but moral issues. And I think the three large things that came up were about the transparency of data, issues of nationalism, and of course about our health systems. If I can just sum up the kind of questions that have come up in the chat. Thank you, Dr. Ravi, for having addressed most of them. But one question that cuts across both the science and the ethics is around the booster, the need for the booster, and whether it is ethical to talk about the booster dose when we've not yet got the first dose to all of our population. So is there the individual right over the right for the public to get the first dose? So for both of you to address that.
I'll go first.
Yes, please
Anand.
go first, Dr. Ravi.
Yeah, as I mentioned in my talk, if you look from the perspective of hardcore evidence, there is none. There is no comprehensive, properly conducted research study that warrants a booster right now. Whether people, I'm happy that people are engaging in a debate. I'm sure Anant will also second me. It is good to discuss these points. There are going to be people who will go and take out the vaccine. And I know of some people who have gone out and take the vaccine, even in India, a third dose. These things will continue, but a larger debate on this has to occur, and to facilitate proper answers quickly, we need trials. We need trials or we need research studies which will say that yes, a booster is needed. I'll stop here. Over to Anand.
Yeah, I agree with Dr. Ravi. I mean, I think the ethics, of course, by itself is important, but it also has to follow the science. And if the science is really not there, we don't really have convincing data which shows the need for a third dose. And, a third dose for which of the vaccines? For example, if I've taken one of the two vaccines which were available widely in India, is it the same for both the vaccines? Now with single dose vaccines happening, it's such a complex area. Of course, we want to make sure that we protect those who might be most at risk. So if there is a need for a booster dose and it is backed up by data, especially for subgroups of populations, then that is something worth considering. But I don't think we are there yet. Yet we have to also recognize that this is an equity issue. The fact that a lot of people who have easier access to vaccines are talking about taking a third booster dose. Yet there are segments of the population which we still have not reached, both globally and also in India, as Dr. Ravi also highlighted. So perhaps that's the one we should be highlighting. Yet as the evidence gets generated, of course, and if there is a vaccine surplus, certainly we can talk about boosters as well.
I just have this last question, maybe, is have our health systems been positively impacted with this whole effort in getting COVID-19 vaccines to the last mile? While you talk, Anand, of the fallout of people other diseases getting neglected, I want us to reflect on whether there's been a positive impact on our overall health systems. Dr. Ravi first.
What should I say about the last mile? I alluded to it in a different way than what you asked, saying that not everybody is going to come to a healthcare facility to receive a vaccine. So we'll have to really find, and that's a challenge not only for COVID vaccine, and I'm sure Anant and all of you know that it's not possible to deliver, within inverted quotes, a vaccine to people always. So I think we'll have to really start thinking about those strategies right now, because it will have implications for other vaccines as well. If you ask a man on the road who's toiling for 12 hours to get a few rupees to give up his job and come and stand in a queue and take a vaccine, or digitally do something on a phone and get registered, I mean, the first 60-70% I said will cover very fast, but the remaining, we have to enable them to accept a vaccine from our side. That last mile is going to be a challenge. I do not have answers. Maybe Anand can.
Sure. So I would tend to agree. I think, good, solid public engagement, community engagement, which also is evaluated, because, sometimes you tend to think that just because you have posters or politicians or film actors talking about vaccines, people will take it, but you don't really engage with some of their concerns. But I think your question had another element to it, which was around what might be some of the positives. And I think one of the set of positives is the recognition that health is important, right? And if this pandemic has reinforced that, it's for all of us within the health sphere to leverage that in making it a political issue, so that our policymakers are asked at each level, in your local municipal elections, in the state elections, in the national elections, what is your plan to reform health systems in this country? What is your plan to invest more in R&D? What is your plan to enhance laboratory coverage? What is your plan to ensure that primary health centers work? If we don't do it, then I think this pandemic experience, we have failed, literally, because, we can go through this, but who knows how many pandemics are on the horizon? We really don't know with the kind of climate change, deforestation, the human-animal interactions which are happening, that what else we'll be facing over the next few decades. So the time is now. It was probably yesterday, but the time is now to question our politicians about their plan and ensure that we keep pushing them on those issues.
Thank you very much, both of you. I think that's a good positive note to end on. A lot to think about, a lot to reflect upon. With that, I'd like to call our a new Associate Director of the College and Research Institute, Reverend Dr. Charles, who is a moral philosopher and an ethicist, and I'd asked him to come and hand over a tribute of our appreciation, first to Dr. Ravi.
Yeah, Dr. Ravi, we thank you very much for your excellent and very informative talk, and especially for your insights on the science of COVID-19 vaccines. On behalf of St. John's National Academy of Health Sciences, and as a symbolic gesture, I would like to virtually hand over a plaque to you as a token of our appreciation. Thank you very much. You have received it already. Thank you. We are very happy about it. Yeah.
Thank you, Father Charles. And now if you could do the same symbolic gesture for Dr. Anant Ban.
Dear Dr. Anant Ban, thank you so much for an excellent lecture and also for sharing your thoughts on the ethics around COVID-19 vaccines. Again, on behalf of our St. John's National Academy of Health Sciences, and as a symbolic gesture, I would like to virtually hand over this plaque to you as a token of our appreciation. Thank you so much. Yes, thank you.
I call upon our Dean, Dr. Tony, to deliver the vote of thanks.
Thank you, Manjulika. It's my privilege to propose the vote of thanks for the third Professor Prakash Shetty public lecture this evening. On behalf of St. John's National Academy of Health Sciences, I'd really especially like to thank Dr. Ravi and Dr. Anand Ban for delivering this year's lectures. Thank you for enlightening us on the various aspects of the science of the COVID-19 vaccines. You made it so simple and easy for public to understand as well, and we're very grateful for that. Thank you, Dr. Ban, for enlightening us on the ethics around the COVID-19 vaccines, a difficult area, but you made it again easy for us to assimilate. Your respective lectures were very informative and insightful, and I'm sure there are several lessons we take home from here. We really appreciate you accepting our invitation to deliver this lecture in spite of your busy schedules. So we're very grateful to you both. I'd also like to thank the family members of Professor Prakash Shetty present here in the audience, and especially like to thank Dr. Nandini Shetty, his wife, and his children who are here online and for facilitating this lecture. I would thank Professor Kurpat, founding dean of the St. John's Research Institute, and a mentee of Professor Prakash Shetty for giving us personal touch and sharing thoughts about Professor Prakash Shetty. Thank Dr. George and Manjulika Vaz for introducing our speakers this evening, and Reverend Dr. Charles for virtually presenting the plaques to our speakers. I'd also like to thank Reverend Dr. Paul Parutaram, our director, who's joined us this evening. Thank you, Father Paul, for joining us this evening and for your constant support and vision within the Academy. You've helped support research and all other aspects that come along with it within the Academy. So thank you so much. My gratitude also goes out to all the colleagues from the Division of Health and Humanities for their efforts in organizing this lecture. And thank all the participants, the other executives, students of Professor Prakash Shetty who have joined, dignitaries from the government and other institutes, faculty invitees, and guests for taking time off this evening to attend these excellent lectures by Professor Ravi and Dr. Pan. And finally, a big thank you to the technical team led by Mr. Prajit Maharaj and colleagues, and the informatics team led by Dr. Deena, Dr. Ryan, and Rajan, and other administrative teams behind the scenes to make this lecture a success. Thank you all once again. Good night, and have a pleasant evening. Thank you.
Thank you, everyone. I'm just using this opportunity to inform you that next week there is another oration, the Bhatia oration, very close to Prakash, Dr. Prakash Shetty's heart. Like Anura said, he was connected with the history of medicine. So we have one of his friends, the Dr. Dagmar Wujistik, who will be delivering this talk on the history of Indian medicine and alchemy. So do join us. My colleague Radhika is posting that link in the chat box before we close. Thank you. Goodbye.
Thank you.